Hello.
Good morning, sir.
Yeah, good morning, Andrea. How are you doing?
I'm fine, sir. How are you?
Yep, very good. Thank you.
So I went through the recorded video. Y'all did the other theorems, right? I had no doubts. It was very well explained.
Oh, okay, great. So that's circle theorems, right? Yeah.
Yes, sir.
And today I think Naren will not be coming in for class. He has some commitment. He messaged me.
Yes, sir.
So we can take on whatever topic you want, whatever doubts you have, we can
Yes,
do
sir.
that.
Actually, throughout the week, I usually get up in the morning and do math. So all the doubts I had, I actually piled them up for today.
Actually,
Yeah.
you sorted them out or you
No, no, no,
collected.
no. I collected them.
Oh, that's brilliant. Okay. Um, we can take on those problems. If you had any, we can clear those doubts.
Yes, sir. Okay. Um, just a second. So in the chapter ratio and proportion, I started off having doubts over there.
Ratio and proportion.
Yeah, and we don't have ratio, so it only starts in proportion.
Only proportion, right?
Yeah.
Okay. So any particular sum in that
Yes.
that was a bit.
So in 7B, I have doubts in I wasn't able to solve the 12th, 13th, and 14th sum in 7B.
Proportion 7b, is it?
Yes.
Let me just check. Yeah, I got that. 7b, right?
Yes, sir.
And which sums did you say?
So the 12th, 13th, and 14th.
12, 13, 14. Okay. Okay. I think 12th one is it the one that says if y is the mean proportional between x and z, prove that and some long thing.
Yes, sir. Yes, sir.
Okay. All right. So in these kind of sums, right, very similar to trigonometry, you can't take them both parallelly and solve them. Okay. What? So I'm going to write the sum down for the benefit of the video. If y is the y is the mean proportional between x and z, between x and z, prove that. And it says x squared minus y squared plus z squared divided by x power minus 2, right?
Yes, sir.
Minus y power minus 2 plus z power minus 2. All of that is equal to y to the fourth power. Okay, so this is what we've got to prove. So this is very similar to trigonometry in the sense that you can't take this whole thing and write it as an equation and solve it. So you've got to either take left hand side and then solve it, and prove that, the conclusion is equal to the right hand side or vice versa. Or you can separately take left hand side in one column and another column right hand side. And if the results are equal, then it's fine. So either of those methods, either of those three methods you can use. All right. Basically, you can start either with only left hand side or with only right hand side, or you can start both but in separate columns and then prove that they're equal to some result.
Okay, sir.
So we know one thing, that in a mean proportion, in a mean proportion, in a mean proportion, let's say if x is to, let's say for example, y is to z, right? Because it's said here, I'll just write that clearly. Because it's said here, y is the mean proportion between x and z, right? So in that mean proportion, this is what it will look like, right? Not if, but in the mean proportion, let's put it that way. In the mean proportion, right? X is to y, which implies that y squared is equal to xz. So in a proportion, right? These will be equal. Xz, the extremes,
Yes, sir.
will be the product. Extremes is equal to the product of the means. So this is the first conclusion that we can come to from here. And what we can do is we can start with the left hand side. We can start with the LHS. So LHS or left hand side is equal to x squared minus y squared plus z squared divided by x to the minus 2 minus y to the minus 2 plus z to the minus 2. Now, what does this mean? This means x squared minus y squared plus z squared. And that minus 2 power is actually 1 over x squared, right?
Yes,
X
sir.
power 2 is x power minus 2 is 1 over x squared, right? So
Yes, sir.
this is 1 over x squared minus 1 over y squared plus 1 over z squared. So you're following up to here, no problem.
Yes, sir.
Here, because of lack of space, I'm just moving to this column. Now we'll make our first substitution. You know that this is, so this chapter is all about making that substitution, especially where mean proportion is concerned. You know that y squared is equal to xz. So we'll take these y squareds and turn them into xz's. So I'm going to write that down as LHS is still equal to x squared minus xz. Instead of y squared, I've written xz plus z squared divided by 1 over x squared minus 1 over xz plus 1 over z squared. So it's just the two replacements that I've made here, substitutions. That's the xz and the xz instead of y squared, right?
Yes, sir.
That okay? Now I'll take the LCM for the denominator. That's all I'm doing. So here I've just substituted because y squared is equal to xz. Now I'll substitute, I'll just sort the LCM for the denominator. So numerator stays the same. X squared, and is misbehaving a little bit. One moment. X squared minus xz plus z squared divided by, and LCM of this denominator is, it's just x squared z squared. Okay. If you notice the denominator's LCM, do you know how to find the LCM for the denominator?
So yes, sir.
You're fine with it? You know how x squared z squared came about, right?
Yes, sir. Yes, sir.
And this is from a lower grade. Okay. All right. So I'm going to move to the numerators. So what do? You divide this by each of the denominators to get that corresponding numerator. So x squared z squared divided by x squared leaves you with z squared. Z squared into 1 is z squared. And minus, say, similarly, xz, right? Plus x squared. Were you okay with this?
Yes, sir.
Any doubts? Don't hesitate to ask. Right?
Okay, sir.
And yeah. Um, okay. So from here, we'll see if we can cancel anything out. Um, so I'm just going to move the page here because I'm going to divide this by this. Okay. So I'm going to take this numerator and divide it by this. Okay. This sign, I'm going to, instead of the fraction sign, I'm going to divide. That's fine, right? Because
Yes, sir.
if I
Yes,
have
sir.
by 4 as a fraction, I can say 3 divided by 4. Correct?
Yes, sir. Yes, sir.
Down as, okay. So it's going to be x squared minus xz plus z squared. That's my numerator. Divided by, and when I divide, I invert this, right? When I'm dividing by a fraction. Oh, okay. I inverted it, right? Multiplied. But I'll still write division and then we'll change that. So in a fraction, you have, if you have 2 divided by 3/4 or something like that, you write 2 divided by 3/4 and then you turn that into 2 into 4 by 3. You're familiar with that, right?
Yes, sir. Yes, sir. Yes, sir.
Basic stuff. Okay. So can I straight away use a multiplication sign because we are
Yes,
lacking
sir.
into x squared z squared by z squared minus xz plus x squared. If you notice closely, this numerator and this denominator are exactly the same. If you notice
Yes, sir.
closely,
Yes, sir.
there's an x squared here, there's an x squared here, there's a z squared here, there's a z squared here, and there's a minus
Minus
x
X,
and
sir.
minus z. So this can be cancelled away. Okay? And what you're left with is x squared, z squared.
Oh, okay, sir.
1 minute. There's still a long way to go, but this is it. I don't know if I can erase this and continue on here. But since we have the video, you should be fine. Do you want to write this down up to this
So I'm
point?
writing it down as you're saying it. I'm as yeah, as you're saying it, I'm writing it.
You know, when you're done, okay.
I'm done, sir.
That boiled down to x squared z squared only. That's all that was left after the cancellation.
Yes.
So this can be written as
X
xz
the whole square.
the whole square.
Yes, sir.
Xz, if you remember early in the thing we discussed,
Y
because
square.
yeah, correct. X is to y is to y is to z, which meant that y squared is equal to xz,
X Z.
right?
Yes, sir.
So you remember that. So xz
Yes.
can be placed as y. I'm sorry. Yeah,
Y square.
y squared squared. Is that okay?
Yes, sir.
Is equal to y power 4. And if you remember, the right hand side of this is
RHS.
was y power 4, right?
Yes, sir.
That's fine. So actually, we did not do anything complicated here. We just substituted in the beginning, instead of y squared, we wrote this thing, right? Just going
Yes, sir.
back. We have this previous page, yeah. So in the previous page, what we did was, if you just review the sum, we started with this LHS is this, right? Then we wrote it down because the power of -2, I wrote it as 1 over x squared. I reciprocal the fraction instead of writing it as a negative power.
Yes, sir.
Then I substituted here. Instead of y, I put xz. Or instead of y squared, I put xz. Okay. Uh, and then what did I do? I took the LCM next step. And I just wrote it in such a way that it was easy for me to find the common term and cancel it. That's it. That's all that was there. The next page, I simplified it and wrote the x squared z squared as y to the 4th power.
Yes, sir.
So try this out later today at home
Okay,
once
sir.
again, because this solution is in your mind, and if you actually uh, go over it, you'll sort of firm up that knowledge, and you will not forget it for a long time,
Okay,
at
sir.
least times. Yeah, this is okay. Done. Let me know
Yes, sir.
if you
Done.
move
Done,
to
sir.
the. Okay. But, so it says given that quantities A, B, C, D are in proportion. The next one is that one, right?
Yes, sir.
Given A, B, C, D are in proportion. Are in proportion. Show that it's A minus C into B squared. A minus C into B squared is to B minus D into CD is equal to A squared minus B squared minus AB is to C squared minus D squared minus CD. So that's the one, right? That's the sum.
Yes, sir.
Sum number 13 from exercise 7B. So there are many ways to solve this, and one of the methods is to use what we call the K method. So I'm going to use that one to solve this today. Okay, so we'll say I don't know if you know the K method. It's let A by B equal to K, and since A by B, so in a proportion. Okay, let me actually start from that aspect. So in a proportion, A is to B is to C is to D, A by B is equal to C by D, right?
Yes,
It's
sir.
fine. Let this be equal to K. So let A by B equal to C by D equal to K. So that's why we call this a K method, because we equate those two ratios to a constant called K. Okay. It's simpler to use because instead of saying A by B and C by D every time, we can just substitute it with that one letter K. Okay. So since A by B is equal to K and C by D equals K, therefore A is equal to BK and C is equal to DK. Is that fine?
Yes, sir.
These two are important because we're going to use them throughout the problem. Okay. You wrote this down, right?
Yes, sir.
In a sense, this is our left hand side. Okay. This is our left hand side. And of course, the other one becomes the right hand side, but we'll start with the left hand side. So just write this as RHS. I've got to memorize the RHS because if I start with the left hand side, I've got to prove the right hand side. Okay, A squared minus B squared minus AB, C squared minus D squared minus. Okay, got it. Okay, so LHS is equal to A minus C into B squared, the whole thing divided by B minus D into CD. Is that fine? I've just written it down.
Yes, sir.
Just
Yes, sir.
as it is. I've not done anything on it. Instead of the proportion, instead of the ratio, I've written it as a fraction.
Okay, sir.
Okay. Now all I'm gonna do is substitute. Instead of A, I'm gonna write BK. All right. And instead of C, I'm gonna write DK. Uh, wherever that comes, A and C, I'm gonna substitute them. That's it, right? That's the three places that they appear. So yeah, that means A will be BK minus DK into B squared divided by B minus D into, instead of C, I'll substitute that as DK into D. Right?
Yes, sir.
So all I've done is I've just substituted, nothing, no magic or anything there, just a simple substitution. These three things were substituted. Okay. Now I'll just straighten this out over here. I'll just straighten this out. So I'll just write it a
Sir,
little. Yes.
so wouldn't that be D square? Why couldn't it be D square? D square
At
K. On
the
the
bottom.
yes, sir.
Yeah, I'm going to write all that down. Yeah.
Okay, okay.
Yeah, I'm going to just straighten that out. You're right. I have to just put it together now. I wrote it because it was just a substitution for C, and I just wanted to highlight that substitution. Yeah, but you're right. You can write it as
Okay,
D
sir.
squared. So that was my objective in the next. Yeah, absolutely right. So let me just straighten this out. Now, in this, I can take out K common, right? In the numerator, there's a BK
Yes,
minus.
sir.
I can take the K common from there. So I'll write that as K into, and then there's a B squared. I'll write that as B squared into B minus D. Okay, is that fine? Okay, I'll write it separately if that's a little
Yes,
confusing.
sir. It's
Hang on.
fine. It's fine.
Fine, right?
Yes, sir.
A into, I'll write that as B minus D, and I'll just retain that B square. I can write it here. It's the same thing. It doesn't. That's a minus sign there for minus D. Okay, B minus D into B. So that's the numerator. And in the denominator, it's still, in the denominator, I think I will just write it as B minus D into D squared K. You're right, D squared K. We can put the D's together. That is D squared K. Okay, so there is something that's cancelable here, right?
Yes, sir.
There's a that cancel. There's b minus d, the whole thing that could cancel as well. So this boils down to b squared by d squared. Is that okay? So
Yes,
all I
sir.
substitute, factorize, and cancel. Let's see if I can fit the right hand side also here. Okay, so that's my left hand side, all right? That's my LHS, and I'll just box this and keep it. Now what I'll do is separately, I'll take the right hand side. So my right hand side is a squared minus b squared minus ab, a squared minus b squared minus ab, a whole thing divided by c squared minus d squared minus cd. Okay, and that would equal to, again I'll substitute here, instead of a squared I can write as b squared k squared, right? This a squared,
Yes, sir.
instead of a is equal to bk, so a squared will be b squared k squared. So that's b squared k squared, okay, and minus b squared minus ab. Again, the a I'll substitute over here as bk. This a gets substituted as bk minus bk into b divided by c squared. C again you can write as dk, or c squared is d squared k squared. Uh, c is d squared k squared minus d squared minus cd. So instead of c, I'll write dk. Okay? I'll write as dk. dk into d. Is that fine?
Yes, sir.
Those substitutions. Okay. So now I'll factorize out b squared from each term. Okay, if you can, as you can see, there's a b squared in each of these terms. This is b into b, which is pretty
Yes,
much.
sir.
So I'll take the b squared out. B squared into k squared minus 1, because b squared minus k. Is that fine? Divided by, this time I'll take out, I think d is the common term. So, I mean d squared rather, d squared, there's a d squared, and then this is also d squared. You can hear me clearly, right,
Yes, sir.
Andrea?
Yes, sir.
So d squared is going to be taken out here, factorized out pretty much. So k squared minus 1 minus k. Okay. That term is common, right? K squared minus 1 minus k.
Yes,
So
sir.
that's cancelable.
Cancel it.
And you can just quietly cancel this away. So you're left with b squared over d squared, which is the right hand side. B squared over d squared. And if you actually look carefully, the left hand
It's
side
equal.
and the right hand side are
Equal.
equal. So therefore, since LHS is equal to RHS, uh, hence, okay. It was easy, right? It was not,
Yes, sir.
I mean, it looked a little complicated because of the way the sum was set up with all of those squares and brackets and those two dots here and there.
Yes, sir.
But in reality, if you use that A is equal to BK, I personally I like that this K method. There are other methods, but I feel this is easiest to explain and understand.
Yes, sir.
So we can move on. We can go to the next one.
Yes, sir. The 14th one.
Want to give that a go,
Okay, sir.
or uh, try it if you're okay with it. Give yourself about a few seconds. See if you can get an approach to that problem. While I write it down, while I write the question down, see if you can get an
Okay, sir.
approach. And fantastic. 14th one. Find two numbers. So I'm just reading out the sum. I've written it down. Find two numbers such that the mean proportional between them is 12 and the third proportional to them is 96. Okay. Okay. Any breakthroughs?
So when they say mean proportion, like the previous sum, the y, so is it 12 that way?
Um, yeah, yeah. You can correct. I mean, mean would be, you have, say, let's just assume that it says find two numbers. Let the two numbers be some A and B, let's say. Let the two numbers be A and B. Yeah, now tell me what's the next step going to be? Okay, we've declared the variables as A and B. Yeah, so what would it mean when I say when I say yeah, 12 is the mean proportional between them.
So A is to B is sorry, A is to 12 is equal to B is equal to 12 is to B.
Correct. Or you can say that AB is equal to 12 squared, right?
Yes, sir.
Which is of course from A is to B, as you correctly said, or A is to 12 rather. A is to 12 is to B. Because this means that this is a way of expressing the fact that 12 is the mean proportional to A and B. Okay, so this is this way of expressing that sentence. Okay, all
Yes,
right.
sir.
So once you've written this down, this becomes important because later you'll use it somewhere. Okay, so just keep that in a place where you can easily see it. Okay. So AB is equal to 12 squared. You can even simplify that, and you can say that AB is equal to 144. Therefore, let's say B, for example, is 144 by A. Maybe we can substitute it somewhere. So these two results might come in handy later.
Okay, sir.
Okay. And the third proportional to them is 96. Okay. It says the third proportional to them is 96. Which means that if I were to write, so I'll write that in a different color. Okay. So third proportional to them is 96, which means third proportional is in a mean proportion. A is to B is equal to B is to that number is a third proportional. Okay. Is that fine? So A is to B is to B is to whatever number comes there, that is the third proportional, right?
Yes,
And
sir.
that's in a mean proportion. Third proportion and mean proportional comes only in rather continued proportion. Okay. It's the fourth proportional that's there in a regular ABCD proportion where four numbers are.
Okay, sir.
The third proportional. So this can be expressed as B squared is equal to 96A. Correct? B squared is
Yes,
equal
sir.
to
Yes, sir.
6A. Sum of, product of mean is equal to product of extremes. So we already have something for, B is equal to 144 by A, right? And we
Yes,
can
sir.
substitute that. Let me just make a small column or something here where I can substitute this. So I'm going to continue this here, okay? B squared is equal to 96A. Also, you know that B squared could be 144 by A squared. I'm just substituting for B, okay? Is equal to 96A. Is that fine?
Yes, sir.
So now it looks reasonably simple to to sort of progress from here. So 144 into 144 by 96. If I bring the 96 over to this side is equal to A cubed, right? Is that okay? Andrea, have
Yes,
I
sir. It's okay.
no, this is fine, right? This
Yes,
is
sir. Yes, sir.
like basic algebra. Shouldn't be
Yes.
that
Yes.
trouble. If I simplify all of this, I would get, let's try and simplify this. So I get, which number can I use here? I can use 12, right? 12 eighths are 96 and 12
Yes, sir.
12s 144. And again, 8 might go in, okay, let's simplify. 4 goes 3 times, 4 goes twice, and 2 goes 72 times. Okay. So we arrive at A cubed is equal to 72 into 3, which is
So
3 to.
216. Yes, sir.
I don't know if you know how to solve this, but if you were to use the prime factorization method, it becomes very, very simple. But let's simplify matters. Let's not get into the nitty gritty of solving cube roots. You know that 6 is the cube root of 216, right? So A cube or A is equal to cube root of 216. Therefore, A is equal to 6. So we found what A is. And you know that B from here itself, B is equal to 144 by A, right?
Yes, sir.
Therefore, B is equal to 144 by 6. And that is, I think it's 24, right? 144 by 6. Therefore, B is equal to 24. So these are the two numbers. You got this, and I'll just take you through the skills that we used on this, or the method that we used on this. That once you write it down, let me know. I'll take you through it from the beginning.
Yes, sir. Done. Wrote it down.
And okay, so in the beginning we declared the two variables A and B. Okay, we said let the two numbers be A and B. Then we express them because they are in a continued proportion. The moment they say that two numbers such that the mean proportion between them is 12, it's understood that it's in continuous proportion, because mean proportion is only there in continued proportion. So we concluded from that that AB is equal to 12 squared from here. Okay, and then since AB is equal to 12 squared, or AB is equal to 144, we concluded that B is equal to 144 by A. This result could be used later on. Okay. Now there was another condition, and we took that separately. The other condition was, and the mean and the third proportional to them is 96. So that's a separate criteria. So we wrote that down separately. A is to B is to B is to 96. So from that, we can clearly say the product of means is equal to the product of extremes. So B squared is equal to 96A. And from that, we proceeded into this. We substituted for B squared as being 144 by A, the whole squared, and so on and so forth. And from there, it was rather simple to find. We had only one variable, A, and we found that A was 6, and then B was 144 by A, so it was 24. Is that okay? You
Yes,
followed?
sir. Yes.
More than writing it down, did you understand these, the three that we did so far, 12,
Yes,
13,
sir.
and
I did.
but try them out again, because when we solve it here in class, it looks reasonably straightforward. But sometimes unless you practice it once at home, you may forget one of the steps, so you may not be able to recall. But
Okay,
please
sir.
do that.
Okay,
That
sir.
you
Will do.
don't have trouble after that. The more you practice, the easier it becomes. Okay.
Okay, sir.
So what's the next doubt? You okay with the rest of the problems on this chapter, or
Yes, sir. I worked out the rest. Oh, wait 1 second, sir. I think I had a doubt in 7C.
7C? Okay. Which one was that?
So the 10th one, the second part.
Second subdivision of the 10th one. Okay.
Yeah, 7C.
Okay. All right. I have the book here, so that should be if A, B, and C are in continued proportion. That's the one, right? So 7C,
Yes, sir.
10 sum. Okay. So if A, B, C are in, let's write that down. If A, B, C are in continued proportion, prove that you wanted the second subdivision, right? Which is A squared plus B squared plus C squared
Yes, sir.
is plus B squared plus C squared divided by A plus B plus C the whole squared is equal to a minus b plus c divided by a plus b plus c. Is that, have I got that right? Let's check and see.
Yes,
The
sir.
plus minuses get mixed up while copying the sum, but seems to be okay, right? Yeah. Again, we'll since these are in continued proportion and you have ABC, right? So solution, okay. Since A comma B comma C are in continued proportion, A by B is equal to B by C, right? A by B is equal to B by C, correct?
Yes,
And
sir.
we this is equal to K. Let it be equal to K. K is some constant, okay? K is some constant. We don't know what that is, but some constant. And we are not even interested because it's just a proof. Okay? We're not interested in finding its value is what I meant.
Okay, sir.
A by B is equal to B by C, because instead of writing, through the sum, instead of substituting A by something as A by B and something else as B by C, it becomes very tricky. So instead of that, we can just use one letter to solve it. So from that, we can conclude that A is equal to, very similar to what we did last time. A is equal to BK and C is equal to, B is equal to CK, sorry, right? So because A by B is equal to K, so A is equal to BK, right? And B by C is also equal to K. So B is equal to CK. Is that okay? Is that all right?
Yes, sir.
So these are important results. I'm just going to put in a box. Okay. Okay. So yeah, we'll start with the left hand side. Okay, one more thing you can look at over here. I just observed it, and if you see A is equal to BK, right?
Yes, sir.
So which we could also say that since B is equal to CK, so we could also say that instead of A is equal to BK, we can substitute for that B over here. B is equal to CK. So A is equal to CK into K, which is CK squared. Is that fine?
Yes, sir.
That one. That's all we need. Okay, so with these three results, let's proceed. We'll start with the LHS first, left-hand side. LHS is given to us as A squared plus B squared plus C squared. So what I'll do is I'll substitute right away A squared. Instead of A squared, uh, I have A is equal to CK squared. So I'll write that as A squared is CK squared squared. Is that fine?
Yes, sir.
Plus B squared. So B is equal to CK. So I can write, in fact, B squared is also equal to AB, right? I forgot to mention that. I'll probably write that down as well. Because this is continued proportion, right? So B squared will be equal to AC. Oh, no, 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 sorry. No, what am I doing? My bad. Yeah, B squared is equal to CK squared, right? I'm sorry. B squared is equal to CK squared. Is that okay? Is that all right?
Yes, sir.
Plus C squared. Okay, let's go over this quickly now. Okay, so A plus B plus C, the whole squared is at the denominator. So instead of A in this, I can, okay, this B squared also be substituted, right? Instead of A over here, we can write that as CK squared. CK squared. Okay, plus B will be CK, CK plus C, the whole squared. And now we just from here, we just need to factorize. So many times in these sums, it's just substitute, factorize, and simplify. Yeah. So we substituted, now we'll factorize this. Okay. Um, should I just simplify? I'll take one more step to simplify it. Okay. So the first term that we're looking at is ck squared squared. So that's c squared k power 4, correct? Plus c squared k squared plus c squared. Let me know if there are any doubts, but seems to be okay for now.
Yes, sir.
So in the denominator, I'm going to factorize out the c squared. Okay. So c squared into k squared plus k. Okay, we won't. Yeah, plus 1. Okay, squared. This step, is it clear to you, Anaria?
Yes, sir.
How we took the c squared out?
Yes, sir. Yes, sir.
So in a way, all these terms, the c is actually the c squared because of this. So that's how we were able to take out the c squared. Okay. Just have a look and let me know if this is okay.
Yes, sir. It's okay.
The numerator, we can also factorize out the c squared. C squared, this one, right? All the terms have a c squared. So c squared into k4 plus k squared plus 1, right? Divided by c squared into k squared plus k plus 1 the whole squared. Okay. Yeah, is that fine? Left hand side.
Yes, sir.
The c squares, of course, get cancelled. So you're only left with those two terms. Okay.
So why can't the K4 plus K2 also be squared? Like why can't the square be taken out from that as well?
Um, the numerator,
Yes, sir.
this one. The problem is that last term there, it's only one. No, in fact, it won't boil down to that. Reason being, if I whole square, what will I take out common is the question, right? There's nothing that I can take out that's common. So if I was to take out k squared from that, I'd go with k squared that's left here plus 1 plus then the question mark comes here, right? What am I going to take? Because there's nothing common to all three terms. The k squared, of course, is common to the first two terms, but not everything. Yeah.
Yes, sir. Okay, sir.
Anything else you wanted to ask? Because I suspect that was not entirely a question.
No, sir. I had a doubt with the k4 and then k square, right? Why can't we square, like, you know how the denominator has a square outside?
Okay. Instead of that, you just put the whole thing squared. That's a little, yeah, that won't be possible because I don't know if you remember this. The expansion for k, I mean, not k, but a plus b or something like that. I don't know if you remember that. A plus b is equal to a squared plus b squared plus
Plus
2ab.
2ab.
So, so if I were to sort of, the result for this and the result for this will be quite tricky. Sometimes what happens is we have the tendency to think that a plus b squared was actually just a squared plus b squared, right?
Yes, sir.
So that's what these two look like. But there is this denominator would be a lot different to the numerator
Okay,
because
sir.
of that reason, because there would be that ab or whatever term that's there. So I can't simply take the squared out from the numerator. I can't put it as k squared plus k plus 1 the whole squared. Got it? I think
Okay,
that was
sir.
that was
Yeah, yeah.
there's no more simplification I can do on this. I'll just have to leave it like this for now. And I'll have to move to solving the right hand side. Okay, and I'll have to move to solving the right hand side. Okay. But if you look at it, I mean, we've talked a lot and we've gone all over the place with this. But in solving the sum, so far, all we've done is we've said that since they are in continued proportion, then A is equal to BK, B is equal to CK. And also we said A is equal to CK squared because we substituted for B in that. Right? And then when we were solving, we took the left hand side and all we did was we substituted and we factorized. That's all we did, right? So there's not too much that we've done. I mean, if you're trying to understand the sum, that's all that has happened so far, right?
Yes, sir. Understood that.
So we'll take the right hand side now. And the right hand side is a minus b plus c. We'll try and prove that it's equal to the same result, right? So the right hand side is a minus b plus c by a plus b plus c. Okay, and that is equal to, again, substitute. So for instead of a, you get ck squared plus minus rather b, that's ck plus c by a plus b plus c, which is ck squared plus ck plus c. Right? Again, I factorize out the c from this. I get that as equal to, oh, this is going to be a long one. Okay. K squared minus k plus 1 divided by k squared plus k plus 1, and I take the c out. Is that fine so far?
Yes, sir.
From here, things are going to get a little complicated. Just bear with me on this, okay? It looks simple, but what I want to do is I want to make sure that I get the uh, numerator and denominator similar to the left hand side. Okay, so I might have to do a little bit of uh, simplification here.
Okay, sir.
So I'm going to multiply both numerator and denominator by the conjugate of the numerator. You know what conjugate is, right? So
Yes,
A
sir.
plus conjugate is A minus B.
B. Yes, sir.
That's
Understood.
what conjugates are. So here, I'm going to multiply both these. Let me just write it down a little smaller so I can have space for multiplication. Hold on. Write this. So that's C into K squared minus K plus 1 by C into K squared plus K plus 1. Okay, so I'm going to multiply this by the conjugate of this. Okay, so instead of the minus sign over here, I'm going to put the plus sign. That's the conjugate. If you look at it, the denominator is actually the conjugate of the numerator. So that manipulation is going to help me with both the numerator and denominator. Okay, so when I multiply this by k squared plus k plus 1 and divide it also by k squared plus k plus 1, what I get is, of course, the c's cancel away. What I get is here. So in a way, this is like, this. I separate into these two terms. Okay. So it's like an a minus b into a plus b numerator. See if you can identify that. Is it like a minus b into a plus b? And here,
No, I can't see that, sir.
minus b into a plus b. Is that looking like that?
Yes,
A
sir.
squared is the a and the k plus 1 is the b.
Okay, okay, sir.
That's the only tricky part over here. Okay. And here it's just a plus b into a plus b. So it's like a plus b the whole squared in the denominator. Is that fine? Okay, so it's so a minus b into a plus b is a squared minus b squared, right? So it's k squared squared, which is k power 4, minus k plus 1 squared divided by a plus b into a plus b in the denominator becomes a plus b the whole squared. So k squared plus k plus 1 the whole squared. Okay. Okay. We'll have to simplify this. You just write this down and we'll try and simplify this.
Written, sir. I wrote it down.
Yeah. Okay. So when I simplify this, what I get is, wow, hang on. So the numerator was, just write that, k squared minus k plus 1, k squared plus k plus 1 divided by k squared plus k plus 1 the whole squared, something like that, right? So I'll actually have to multiply this whole thing by this. Okay. So that's k4 plus k cubed plus k squared. I'm just doing good old multiplication, each of these terms with each of these terms, okay? Plus k squared minus k cubed minus k squared minus k plus k squared plus k plus 1 divided by k squared plus k plus 1 the whole squared. So I can cancel away a few common terms here. You're okay with how we got the numerator, right? This is just basically multiplying all these terms with
Yes, sir.
each other.
Yes, sir.
So that's k cubed and k cubed cancel, k squared and k squared cancel, k and k cancel. So we are just left with k4 plus k squared plus 1 by k squared plus k plus 1 squared. And just going back and checking if it's the same as our LHS. Right? The LHS was k4 plus k squared plus 1 the, by k squared plus k plus 1 the whole squared. Yeah, this is the same as well.
So I have a doubt, sir.
Yeah.
On in the previous page, the last part was um a square minus b square,
Yeah.
but then in the next part was something else. So I can't hear you.
I think you can erase that last line. I
Okay.
think from here itself, we can simplify. My bad. So don't worry about that blue bit and that factorization. We can do without it. I think there's not much. That's fine, right? So I'm just erasing all this. Yeah. I think we can just use this and then the next step. Is that fine?
Yes, sir.
Okay. More importantly, you were able to understand all this.
Yes, sir. Finally.
That last part looks a little tricky. Uh, yeah, because we needed to bring in this multiply and divide by the same number. That's the only thing that I can imagine is tricky. So uh, that's something that you'll have to sort of practice. Okay,
Okay, sir.
that multiplying and dividing by that number. So try out the same sums. Let me know if you have any doubts. You're meeting tomorrow morning again, right?
Yes, sir.
Whatever other doubts are there, you can bring them in. Okay, good. In a way, Naren was not there, so you got a chance to clear your personal doubts. Right?
Yes, sir.
All right, Andrea. So we'll wrap it up for today.
Okay,
Anything
sir.
else?
So could you go to the next slide? I just need to copy the last bit down just to make sure. Okay, okay, sir.
When you're done.
Done, sir.
All right. So I'll see you tomorrow. All right. Keep practicing, and like I said, if there are any doubts, you can bring them to me in the morning. Okay. Bye bye.
Okay, thank you, sir. Have a nice day.
You too. Bye.